a red ember from another star has drifted into our solar system, and now, against all expectations, it shimmers with green light. Imagine it, a body forged around a distant sun, traveling for millions of years through interstellar night, suddenly heating as it nears our own star and revealing colors it shouldn't even have. What hidden chemistry makes this possible? What stories are trapped inside its dust and ice, waiting to be read by our telescopes? Tonight, we'll follow 3I divided by Atlas, our third confirmed interstellar visitor, into its perihelion passage, unraveling the data, the mysteries, and the meaning behind its glow. Stay with me, because this journey will change the way you see comets, the solar system, and the galaxy itself. I have spent 3 decades learning how to listen to faint stories told by cold, faraway things, and every now and then one of them answers with a color you didn't see coming. Tonight, that surprise is hanging low over the horizon, a traveler from another star that wears the deep, brick-red patina of age, and yet, under just the right darkness, hints at a breath of green. How can those two truths live in the same sky? That paradox is the doorway we're going to walk through together. Welcome, friends, to Velocity of Comets. Settle in, breathe with the night. Let's read what the universe is writing, one careful line at a time. The object on our minds is called 3I divided by Atlas, 3I, because it is only the third interstellar object humans have ever confirmed, Atlas, for the survey that first raised the alarm. Interstellar means it isn't one of ours. It formed around another star, under another sun, and then, thanks to the rough politics of gravity, was flung into the great common space between stars until chance steered it near our own. That alone would justify every sleepless hour at the telescope. But 3I divided by Atlas isn't content to merely visit. It insists on being interesting. Its coma is growing as it falls sunward, its tail is taking shape, and the light it scatters back to us is behaving in a way most comets don't. If you've ever felt the universe tug your sleeve and whisper, "Pay attention," this is one of those moments. Before we go farther, let's anchor ourselves. NASA's trajectory solutions keep the two most important numbers simple. Perihelion, the closest pass to the Sun, lands near the end of October this year, and Earth stays comfortably far away during the whole show. There is no hidden threat, no secret approach, no reason for fear. Once you know that, you can let your shoulders drop and let curiosity take the wheel. When it comes to objects like this, I'm always grateful for the quiet, relentless work of the people who compute orbits, ping the sky with radar when they can, and feed those numbers into the same deep space network that talks to our spacecraft. Their diligence is why we get to chase wonder instead of rumors. So what makes this visitor feel different? Start with how the light is polarized after it bounces off the dust in the coma. In plain language, that's just asking whether the light's electric field prefers one orientation over another once it's scattered. Most comets dip a little negative at small viewing angles and cross into positive territory around 20 degrees. 3I divided by Atlas dives deeper, earlier, and then flips sooner. To you and me at the eyepiece, that doesn't change the night's look and feel. To a detector, it's a signature written in precise numbers. And signatures tell us about the grains themselves, how big they are, how fluffy or compact, whether they're coated with dark organics or laced with ice. Those are the kinds of details that separate just another comet from this one came of age under a different Sunday. There's also color, our old, untrustworthy friend. Under exquisitely dark skies, several teams have reported a gentle greenish tint in the coma, in addition to the deeper red cast we've seen in other measurements. On many comets, that emerald whisper comes from simple molecules like dicarbon that glow when sunlight energizes them. Earlier glimpses of 3I divided by Atlas didn't show that molecule shouting, which makes the hint of green a fresh and enticing riddle. Is it chemistry turning on as buried ices reach their thresholds? Is it a short-lived jet releasing gas from a pocket with a different mix? Is it the geometry of our view amplifying a narrow band of light? It could be one, several, or something we haven't thought of yet. That's not a cop-out. That's the scientific posture that lets us move forward without fooling ourselves. If you were here with me on an observatory catwalk, I'd trace it in the air. The sun here, the comet there, Earth over here, and the angle between them slowly changing night by night. As that angle changes, the way light scatters changes too, and suddenly we're not just looking, we're measuring. The coma swells because sunlight is digging into layers that have slept for eons. A tail brightens and straightens as forces begin to separate the feather light from the heavy. Some nights you see a fan leaning a little toward the sun, which feels wrong until you remember that large dust grains have stubborn momentum, and jets don't care about our expectations. Nothing supernatural. Just physics, faithfully doing the unexpected the moment you get too comfortable. I want to widen the frame, because this is not just about one comet. Every interstellar object we've met, Oumuamua, Borisov, and now 3I divided by Atlas, has brought the same humbling message. The solar system isn't the template, it's one example among many. The dust that reddens surfaces, the ices that wait for warmth, the organics that get baked into darker coatings. These may be standard ingredients in planetary kitchens across the galaxy. If the light from 3I divided by Atlas is telling us the grains are a little different, more compact here, more coated there, mixed with ices in ways we don't usually see at this distance from our sun, then we've learned something about how other kitchens stock their shelves. That knowledge will echo into how we read young planet-forming disks around other stars and how we model the atmospheres of worlds we can't yet see. This is where the fleet matters. Hubble can carve fine structure out of the faint. The James Webb Space Telescope can warm the dust into view and pick out signatures that ground-based scopes struggle to isolate. The big mirrors on Earth can keep building the polarization curve and catch outbursts in real time. And there's a quiet hero in the background, launch cadence. Because commercial rockets fly so often now, specialized astronomy, payloads, and rideshare missions can get to space with less drama and more predictability. That doesn't mean we can launch a probe to 3I divided by Atlas tomorrow. But it does mean we can start designing nimble spacecraft that wait in high orbits and pounce when the next interstellar visitor raises its hand. 10 years ago, that sounded like a dream. Today, it's an engineering plan people can take seriously. If you feel a little awe pressing at the edges of your chest right now, good, hold that. Awe is not the opposite of clarity. It's the spark that makes clarity worth the work. The next few weeks will bring more data, more plots, and yes, more arguments. Some nights the color will look stronger, some nights it won't. Some measurements will tighten the story, others will throw us a curve. That's the music of discovery. My promise to you, as always, is simple. We'll follow the best evidence we have, and when the evidence changes, our minds will change with it. Let's make this an invitation, not a lecture. I'd like you to walk this road beside me, not behind me. Subscribe to Velocity of Comets, bring your questions, and bring your patience. We'll celebrate the beauty, but we'll also push for spectra when colors tempt us, and we'll ask for repeated measurements when a single night looks too magical to be true. This is the journey companionship I believe in, you and I, side by side, meeting a traveler from another star with open eyes and steady hands. If the green keeps blooming, we'll learn why. If it fades, that too will teach us something honest about light and dust and the long memory of ice. Either way, the sky is speaking. Let's listen together. Do you remember the first tug of wonder we felt back in Part 1, the paradox of a red interstellar body glowing green? Let's pick that feeling back up and let it guide us deeper, because beneath the beauty there is a story written in data points and physical laws. When I first looked at the numbers from 3I divided by Atlas, I felt the same thrill I did when Hale-Bopp was filling the skies decades ago. But this time, the plot on the page bent in ways that didn't match the usual script. That bend is our mystery. Most comets we've studied trace a familiar path on a polarization phase curve. As the Sunday comet Earth angle grows, light scattered by the Coma shifts from a shallow negative polarization into the positive. It's almost like a heartbeat you come to expect. 3I divided by Atlas, though, drew a deeper dip and flipped earlier than the rest. At around 7 degrees, it plunged to nearly 2.7%, and by 17 degrees, it was already climbing into the positive. To you and me, standing under the stars, those numbers don't change what we see with the eye. But to our instruments, they are fingerprints. And those fingerprints suggest dust and ice grains built under conditions unlike those of most comets born in our own solar system. More compact, perhaps, more coated with organics, more akin to the textures we find in trans-Neptunian objects at the frozen edge of our neighborhood. Hypotheses bloom in the light of that curve. One says we may be watching a TNO-like composition darkened by long exposure to cosmic radiation, salted with exotic ices that release differently when warmed. Another says the grains could be larger, less porous, scattering light in ways that push the polarization inversion angle lower. A third idea looks at surface coatings, thin, organic mantles that alter reflectance and shift polarization. Each possibility is testable. That's the discipline of science. Don't fall in love with one answer, let the sky decide. Now we add the riddle of color. On September nights under the Namibian eclipse, images caught a hint of green around the red. Many comets display this hue thanks to dicarbon C2 molecules fluorescing when sunlight hits them at just the right wavelength. But spectra taken earlier in the year didn't show C2 in abundance for 3I divided by Atlas. So how could the Coma glow green? Perhaps as it neared the sun, a buried layer of ices crossed a sublimation threshold, releasing new gases. Perhaps CN played a role, its emissions overlapping and creating the emerald tint. Or perhaps geometry and atmospheric conditions amplified a narrow band of light. These are not exotic explanations, but they are important ones, and astronomers worldwide are racing to gather spectra around perihelion to test them. What we need is direct confirmation. Spectral lines at 518 nanometers for C2, lines in the violet for CN, or other molecular signatures. Until then, the green remains a tantalizing maybe. The Coma itself is telling another story. In July, observers reported a sunward plume, a fan of dust, seeming to point toward the sun, when instinct says a tail should always stretch away. At first glance, it looked like rebellion. But comet jets are not bound by our intuitions. If a vent shoots out large grains with high momentum, radiation pressure won't immediately push them back. For a while, the fan can look sunward before the smaller, lighter particles trace the classic anti-solar tail. Physics allows it. It's not breaking rules, just exploring a corner of parameter space we don't often watch so closely. This is the moment when it helps to address the louder stories traveling through social media. Some claim that 3I divided by Atlas is a threat, or even an alien artifact. But the orbit solutions are clear. Perihelion will happen at about 1.4 astronomical units from the Sun, and Earth stays about 1.8 AU away at closest approach. That is more than 270 million kilometers of safety. There is no danger. NASA, ESA, and independent astronomers have emphasized this repeatedly. And as for artifact, extraordinary claims need extraordinary evidence. What we have instead are natural signs: a coma growing with sunlight, jets venting dust, polarization curves that fit models of exotic grains. That's wonder enough. We don't need to invent more. Where do we go from here? We aim every instrument we have. Hubble can freeze the evolving structure of the Coma in high detail. The James Webb Space Telescope can warm the dust into the infrared and show us particle sizes and temperatures. Big ground-based observatories like the VLT and Keck can extend the polarimetric curve as the phase angle grows toward perihelion. And in Chile, the Vera Rubin Observatory has already proven its power by catching the comet during its commissioning phase, showing that survey astronomy is now ready to catch these fleeting guests on the fly. This is also where new technology matters. Commercial rockets, flying more often than ever, make it realistic to imagine small, nimble spacecraft waiting in orbit, ready to sprint when the next interstellar visitor appears. We can't chase 3I divided by Atlas now, but the blueprint is clear. The marriage of public science and private launch capability means the next time the galaxy throws us a visitor, we may not just watch from Earth, we may meet it out there. So let's hold on to that feeling we started with. Curiosity, sharpened by paradox. A red body glowing green. A comet behaving like a T number. A plume pointing sunward while the tail pulls back. None of these are contradictions, they are invitations. Invitations to refine our models, to stretch our instruments, and to trust that the universe is always stranger and more generous than the labels we try to fit on it. And as we move closer to the 29th of October, every new data point will either strengthen or reshape our understanding. That's not failure, that's the pulse of science. Stay with me. Together, we'll watch the curve extend, the colors change, and the truth settle into focus. This is the moment where the story crests. We have walked through paradox and data, through green glows and tilted curves. Now we arrive at the revelation, not the kind of shock that vanishes with the next headline, but the kind of astonishment that lingers because it is grounded in truth. 3I divided by Atlas is not a comet in the usual sense, nor an asteroid, nor a centaur that lost its way. It is something that reaches across categories, carrying in its coma the fingerprint of trans-Neptunian bodies, and in its behavior, the breath of a comet. This blending is the wonder. It tells us that our neat drawers of classification will never be enough for the wild diversity the galaxy delivers. Think about what that means. If 3I divided by Atlas shares traits with the dark red bodies beyond Neptune, then our solar system is not unique in forging those materials. Radiation-cooked organics, compact dust, ice mantles that awaken only under strong sunlight, these are not oddities reserved for our edge of space. They may be the standard products of planetary formation everywhere. That realization is humbling. For decades, we wondered if the chemistry that seeded our comets, that may have watered our Earth, was rare. With each interstellar visitor, Oumuamua, Borisov, and now 3I divided by Atlas, the evidence piles higher that the galaxy is rich with such bodies, each one a messenger carrying pieces of distant worlds. The consequences ripple outward. First, for planetary science, every unusual polarization curve, every odd inversion angle, is a clue to the dust that once circled another Sunday. By modeling these curves and comparing them to our own comets, we reverse engineer the histories of alien systems. Were there giant planets stirring their disks, scattering planetesimals? Was there a cluster environment where encounters were frequent and violent enough to fling objects into interstellar exile? 3I divided by Atlas doesn't just tell us about itself, it speaks about the gravitational architecture of its birthplace. Second, for technology and exploration. We now know these visitors are not once-in-a-century miracles. They may be once-in-a-decade opportunities. That changes the calculus. If survey telescopes like the Rubin Observatory can catch them early, and if rockets fly often enough, then small intercept missions become possible. Imagine a spacecraft the size of a refrigerator, waiting in cislunar space, fueled and ready. The alert comes in, an interstellar object inbound. Within weeks, it is launched on a sprint to meet it, to fly through the Coma, to taste grains that condensed under another star. That is no longer fantasy. SpaceX, Blue Origin, and other launch providers have made space accessible enough that scientists can dare to plan. The groundwork is being laid now, and 3I divided by Atlas is the proof of why it matters. Third, for philosophy. We look at this green glowing traveler and realize we are not alone, not in the sense of intelligent company, but in the sense of ingredients. Water, carbon, dust, and ice are not parochial. They drift everywhere. They form worlds. They form comets. They form atmospheres. If the building blocks of life are this common, then the spark that animated our planet may not be a singular accident. It may be one note in a galactic symphony of chemistry. That doesn't guarantee neighbors with cities or songs, but it strengthens the idea that the stage is set across countless worlds. Perihelion is coming, and with it, the climax of this apparition. The comet will pass inside Mars's orbit, its activity likely spiking, its coma swelling further, its chemistry shifting as hidden ices vaporize. Every telescope we have, Hubble, Webb, the VLT, Rubin will be watching. Amateurs with backyard scopes will be adding their eyes, catching changes hour by hour. If the green intensifies and we measure strong C2 lines, we will have an answer. If it fades, then perhaps CN or dust scattering carried the illusion. Either way, we will have learned something we didn't know before. That is the real reward. So here is the climax I promised you. 3I divided by Atlas is showing us that interstellar comets are not outliers. They are bridges between systems, between categories, between what we assumed and what is true. They prove that the galaxy recycles material, sharing its chemistry freely across light years. And they remind us that discovery is not about confirming what we already believe, but about being willing to stand in awe when the sky refuses to match our expectations. Let's step back and breathe in the awe together. Picture the green glow against desert stars, the quiet dome of an observatory humming, the graphs on a monitor tracing curves we've never seen before. All of it points to one fact. The universe is stranger, richer, and more generous than the tidy diagrams in our textbooks. That is the gift of 3I divided by Atlas. It widens our imagination, and it calls us to prepare for the next messenger. I want to leave you with a question that belongs not just to scientists, but to anyone who has ever looked up. If you could choose only one observation at perihelion spectra of its green light, high-resolution images of its coma, or extended polarization measurements, what would you pick, and why? Put your answer in the comments. This channel lives on your curiosity as much as mine. Together, we will keep listening to the messengers the stars send us. 3. I divided by Atlas arrived not as an answer, but as a question dressed in light. Its orbit reassured us it will never come close to Earth, but its behavior pulled us closer. Polarization curves bending in unfamiliar ways, jets that sometimes leaned sunward, a greenish tint caught beneath an eclipsed sky. Each of these pieces added to a picture of a visitor unlike any comet we've studied. And yet, through all the strangeness, the laws of physics held. Dust scattered light as dust should. Ices sublimated as ices do. The mysteries lay not in defiance, but in detail. For me, after decades of watching these travelers, the lesson is personal. Discovery is rarely about fireworks. More often, it's about noticing a small curve shift on a graph, or a color bloom where none should be, and realizing that the universe has just whispered a new truth. 3. I divided by Atlas reminds us that interstellar bodies are not singular miracles. They are part of the galaxy's normal traffic. They bring us news from distant systems, evidence that other suns build the same kinds of dust, the same kinds of ice, the same raw ingredients that seeded our own world. The takeaway is profound. We are not isolated chemistries, sealed off in a corner of space. The materials that made us are shared across the Milky Way. Every comet, like 3I divided by Atlas, is a messenger, carrying proof that the story of planets and potential life is written on a universal canvas. So let me ask you, fellow traveler, if you could hold just one answer in your hand, would you want to know what makes the glow green? Or would you rather know what it reveals about the place where this comet was born? Share your thoughts, I want to hear them. And if this kind of journey stirs you the way it stirs me, subscribe, and let's continue to chase these cosmic messengers together.